Good evening, everyone. I'm recording this lecture. That's why you can later watch it. So, till now, we discussed some topics related to functions, arrays, structures. So we discussed that because they will be important for object-oriented programming. And also with this group, I didn't discuss pointers yet, but I will make an extra lecture for that, and we will do it. And till that time, I'm not going to ask anything about pointers, for example, in labs. Okay, let's start. Okay, the main purpose of C++ programming is to add object orientation to the programming language. So object orientation means we will not work with the functions like C programming language. As you know, in C programming language, we have a main function, and also in the part that you didn't use object orientation, in C++, it is more or less same. So there's a main function. Also, you can call another functions. But here, we are going to use object orientation, which means actually we are going to use data and also the method together. So we will create a class, and we will our class will consist of data and objects. There are four main parts of object orientation. One of them is encapsulation, the other one is abstraction, the third one is inheritance, and the last one is polymorphism, which actually we will see some of them as chapters and some of them as some methods. So what is encapsulation? Let's check it. So the meaning of encapsulation is to make sure that sensitive data is hidden from users. So as you know, users does not need to just see everything at the backside. I mean, it is something like you are playing a theater game, play, and at there, behind the skin, a lot of things are happens, but the people that are watching that play is only see in front of the skin, so they cannot see the backstage. So it is something like that. So as programmers, we can hide some data to user, and we can show some of them. So the name of it is encapsulation. So to achieve this, you must declare class variables, attributes as private. So the most important thing that as a programmer we don't want to change by accident or by purpose, so to damage our system. So we can make our variables, attributes as private. What is private? Private means we cannot access outside of that class. So it is called private. We will see what is private in detail. So just try to understand in general frame. So if you want others to read or modify the value of a private member, you can provide public get and set methods. And we can use get and set methods, getters and setters, which means we can just get it by using the functions and set it again by using the functions. So we will see them in detail. Just for here, we have some terms that you don't know yet. So the encapsulation is, you can know as to make sure that the sensitive data is hidden from users. So the other one is abstraction. So actually, encapsulation and abstraction is similar. Is the process of only showing the necessary details to the user and hiding the other details in the background. So here we don't need to show user all details. So it is called abstraction. Abstraction is a kind of look. For example, you have a calculator, and you can see only numbers and the symbols, mathematical symbols. So you don't know what's going on at the background. I mean, you don't need to know about when you press equal, which circuit will be activated or something like that. So this is to make the user's task simplified. So make it to use it more easily. Okay, so as a programmer, we can do also the similar thing. We can make abstraction to just hide the unnecessary details. So abstraction in C++ is achieved through classes, header files, and access specifiers. So this is the general build of object-oriented programming. So also we will see the these terms and the other things in more detail later. The third one is inheritance. So the inheritance is the capability of a class to derive properties and characteristics from another class. It's called inheritance. So sorry. Okay. So inheritance is something like we can just derive some other class, and that derived class will take the features of its base class. From this image, I can explain you. As you see, we have a base class which it has some functions, eat and sleep, okay, as a generic features of an animal. And the derived class have bark feature, which it is, its name is dog. So this bark function is belongs to dog class, but also it has all the features of eat and sleep functions. So this dog class can have access easily to animal class. But when we see it with examples, it will be more meaningful, but we are in just theory now. So this is called inheritance. So inheritance is a feature of a process in which new classes are created from the existing classes. The new class created is called the derived class, like this. So we have an animal class. If we created another class from this animal class, it is called derived class or child class. And the existing class, this one, like animal, is called base class or parent class. So we can say the derived class, this one, is said to be inherited from the base class. So this will take all the features of this animal class. So it is just similar to real inheritance. The last one is polymorphism. It means many forms, which it occurs when we have many classes that are related to each other by inheritance. So it is, look, something like we have animal, okay, animal base class. We can create a cat class, for example, horse class, something like that. And maybe each of them have a feature, common function, but it is like different for each of them. So like we specified in the previous slide, inheritance lets us inherit attributes and methods from another class, and polymorphism uses those methods to perform different tasks. So this allows us to perform a single action in different ways. So when you call, for example, if we create a cat class, and let's say we have a common function. Let's say instead of bark, let's say we put sound, and for the cat also we put sound. So when we run sound for cat class, it will have other action. When we run sound function for dog, it will create another action. So this is called polymorphism. So similar example is given here. Think of a base class called animal that has a method called animal sound. So derived classes of animals could be pigs, cats, dogs, birds, and they also have their own implementation of animal sound, like pig oinks or the cat meows, like that. So this is polymorphism. We are calling the same function name as name, but it's because of different classes will be activated, it will be different actions. So these are the four main pillars. So mainly we can say that the object orientation tries to make our codes more simplified. I mean, how can I say, we can reuse a lot of codes by this way. We can also make our programs to be more simple for the users. We can hide details, and also we can just in the encapsulation, we can hide some sensible data like variables or attributes. So, and also we can just derive some subclasses. In this way, we can use our codes. I mean, we don't need to use, we don't need to write same codes again and again. So, as I told you, these are maybe will be understood when we just have some examples, spend more hours on this lecture. So just try to mainly understand what's going on. For example, for this time, the explanation is enough. If you have problems about understanding the others, one by one, I will explain everything. Okay, so the classes are the central feature of C++ that supports object-oriented programming. So in object-oriented programming, we are writing classes, and these classes consist of the functions and the variables. So as you see here, fields, these are variables, I mean string, integer, something like that. And these are methods or functions, rotate, move. So the variables that we are using in traditional programming, and also methods that we are using in traditional programming. So actually we are going to use something that we already know. And from classes, we are creating objects. So you can think classes, we can make it's, how can I say, you can think that classes are the like functions. When we write a function definition, that definition will never work if we don't call that function inside the program. So writing classes is something like that. A class will not be activated if we don't create an object. So we can say that classes and objects are a kind of instantiation of an object, of a class. Or we can say that classes are blueprints and objects are just the real thing. So, like in structures, we write a structure, but we can create several kind of objects. It is similar in object-oriented programming. And as you see, in classes, we are defining the generic things, and we can just, in objects, we can give some values. like object 1, object 2, object 3, and for example, as size. Okay. So in the past, information systems used to be defined primarily by their functions. So what we are doing in traditional programming, we are inputting something and we are outputting something. Like you put, think about that, you are working in a fabric and, for example, you put some ingredients and you will take some product. For example, you put some spice, meat, something like salt, something like that as input, and you will take, for example, sausage as output. So this is actually the what a function doing. In functions, for example, we are inputting the, for example, two different operands. And if the function is related to add two numbers, so I will enter 2 digits, and this program, I mean, this function will calculate me that 2 digits and give the out. So this is the task of a function. But in object-oriented programming, we are not using only functions. We are using classes, which is inside the class, we have both data and the functions, and also that classes can have relationship with each other. Of course, we will arrange it. If we need to make a relationship between classes, we can arrange it. Okay, let's continue. So, from classes, we are creating objects, and that objects are have some attributes. I mean, the data. Data are simply we can say the variables. And the behavior of these objects is described by methods. So the attributes are the variables, and the behavior are the functions. Okay, actually, because of you didn't see C language before, I think you just start from C++. But actually, the part of the programming language, I mean C++ without object orientation, is very, very similar to C. But anyway, we don't need to discuss the difference between them. So, as we discussed in data structures, classes are an expanded concept of data structures. That's why I first showed you data structures, and we made a lab last time. By the way, labs are very important. Please try to come. I made it 2 hours because I want from you to just try there, and you can ask me or Musa, lab assistant, questions. So by this way, you can gain more experience. Okay, so For example, you can't be a programmer without just working on it. I told you before, I think you can't have a perfect body by just watching the people that they are making bodybuilding. So I am trying, it is not working, you can believe me. So just watching is not make you a programmer. Okay, you have to try. So I want to see all of you in laboratory. So by this way, I can understand the level of each of you, and maybe I can help you. I can give you more exercises if you have some gaps. So this is for your own good, and that's why I didn't. I'm not giving points in lab. But by the way, I will give extra points. You will not lose points if you don't come to lab, but I will give extra points if you come. Okay, so classes are expanded concept of data structures. So like data structures, they can contain data members, and also, as you see in structures, if you remember, we have only data members. I mean, for example, in when we create an integer variable, we can have only one value. If the value of integer is 50, only we can store 50. If we create an array with 10 values, so as integer again, we can store 10 different values there, but all of them should be integers. But in data structures, in structures, we can store different kind of data. We can store like records. Okay, what is record? For example, one line of information that, for example, it will hold your age, your hobbies, your country, something like that. So one set of information with different data types is called a record. So in with data structures, we can create records. But the expanded version of data structures in object-oriented programming, we can, as well as data members, we can put also functions. So in data structures, we have only data, but in classes, we have data and the functions together. Okay. So an object is an instantiation of a class. So we can think that a class can be the type and the object would be the variable. Okay, so type is mean like integer, character, whatever it is, if you want to make a similarity, and the variable itself, for example, integer a is the variable, integer is the data type. So we can draw a generic frame by creating a class, and from that class we can create a real object. So like here in this example, a car class, this is the class, and from the objects we can create some objects and some features of it. Okay. A class is used to specify the form of an object, and it combines data representation and methods for manipulating that data into a neat package. So let's go to the next slide. The data and functions within a class are called members of the class. So as I told you, in a class, we have data and the function. So data are the variables, okay? And functions or methods are the behavior. I mean, what we want to do, we can write its code. So each of these data and the functions are called the members of the class. So all of them are members of class vehicle. So if it is variables, we are calling them data members. And if they are functions, we are calling them member functions. So I gave this analogy before. When you define a class, you define a blueprint for a data type. So this doesn't actually define any data, but it does define what the class name means. That's it. What an object of the class will consist of, and what operations can be performed on such an object. So we are not defining each data. Sometimes we can initialize it, but we are not defining all of them. But we can understand what it will be performed by using that class when we create an object. So a class definition starts with the keyword class and followed by the class name. So class name means class, for example, animal. Okay, class animal. This is the class name, and this is the class keyword that mentions to the compiler that we are going to create a class. A class definition must be followed either by a semicolon or a list of declarations. So as you see, we have to start with a curly bracket and finish it with a curly bracket, and also after that we have to put a semicolon. You can think that it is like to create a set of variables or something like that. So we have to put semicolon. It is not a kind of program fragment. That's why it is different from that. So also inside the class, what we have access specifiers. Access specifiers can be either private or public or protected. Okay, it is showing that how reachable is this class or part of the class. And inside the, after the class access specifiers, we can put data members, variables, and member functions. Okay, this is a generic frame of a class. So here we have some member functions, but in the beginning we will not use member functions. We first use only variables, and we will just continue to put some extra features by adding the functions. Okay, so for example, we can define the box class as follows. So this is seconds. Okay. So this is class keyword. This is the name of the class. This is access specifier. So this keyword is just showing how accessible is this values or functions, whatever we put under. These are the variables: length, breadth, height, all of them are double. And as you see, we open the class with this curly bracket, and we close it, and after that we put a semicolon. Okay, so we don't have any function here because the resource just wants it to be simple for the beginning, but we will add functions later. Okay, let's continue. Okay, we set access modifiers. I mean, public, private, protected, or access specifiers. Okay. So the keyword, if we are using public, it determines that a public member can be accessed from outside the class, anywhere within the scope of the class object. So we can have access to any member if it is a public member. So outside of the class, we can make access. So we can also use a private or protected. I will show you later. First of all, just concentrate on public. Let's continue. So as I told you, a class provides the blueprints for objects. So basically, an object is created from a class. So as you see, a blueprint can be a house plan, and the object can be the house itself. Okay. Okay, I am going to stop the lecture and connect in 10 minutes. So after 10 minutes, I will continue.